All right, everyone. Period 9, geometry, my favorite. How's it going? I hope that test yesterday went okay. Some of you were telling me that you spent quite a long time on it, all right? But I also had some people submit it at like 7 a.m. or like 8 a.m. So good for you guys, those of you that did it really early and got it done. But I'm hoping all of those are in. I think I have a couple of late people. So yeah, hopefully I can start grading by tomorrow morning when you're all in. But for today, we're going to be doing a lesson today on Tuesday and also one tomorrow on Wednesday. All right, we'll have homework on each day and they'll be both due on Friday. All right, so today we are going to be doing 2 more theorems, which means 2 more calculator labs and 2 more Euclidean proofs. Isn't that nice? So for this first lab, just read the theorem and see if you can construct what you think you need to construct on your calculator to complete the theorem. All right, this one's actually a little hard because I'm not giving you directions, but just see what you can do. We've done a bunch of these already. All right, so go ahead and pause the video, get out your calculators, and try to see what you can get done here. All right, so I am going to share my calculator screen where I've done some of it already, not all of it. And let's see. So we wanted to find the measure of an angle formed by a tangent and a chord intersecting at the point of tangency, right? And we wanted to find what that is equal to. So here we go. Here is my tangent line, right? And here is my chord that intersects at the point of tangency right there, right? Here's my point of tangency. This line is always tangent. So if you're having trouble drawing in this tangent line, well, what I did is I drew in a radius like this, right? Or I can make a diameter, but just drawing a radius because we know a tangent line is perpendicular to the radius. So what I did is I went menu, construction, perpendicular, right? And I constructed a perpendicular line to that radius, and that's going to be tangent to the circle, right? That was one of our prior theorems. So there's my tangent, and then just draw a chord in. So I measured the angle formed by the chord, that's 80 degrees or 79.6. So what might this angle be equal to? Well, we're doing circles, so it makes sense to measure these arcs. So let's measure the lengths, or not the lengths, the measures of those arcs in degrees. So to do that, we need to draw in the arc first. So that's in menu 4, points and lines, circle arc, right? So go to one of the endpoints of the arc, put in a point in between, and sorry, there we go. There's our arc. And let's measure that arc and see what that says. So measure. So again, your calculator can't measure measure arcs in degrees. It only measures the length of it, unfortunately, unlike Sketchpad. So I'm going to measure the circumference of the circle, 44.8 centimeters. You go here, hit tab. That switches to the circle arc. So the length of this arc is 26.3. That's the arc length, right? So to find the measure of the arc in degrees, well, we're going to do 26.3 over 44.8, right? That's going to be the fraction of the circle times 360 degrees to get the degrees in this arc. So I already wrote that in using text. Now I'm going to calculate this expression with that as A and this as B. And so that is 211 degrees. Huh, not what I expected. That was weird. All right, but there we go. So that arc is 110. Sorry, not this arc. This angle here formed by the chord and the tangent line is 110 degrees. Huh, the measure of the arc is 220. Notice something? And we can drag this around, right? 127, 254, right? 133, 266. So hopefully you're seeing this angle is half the measure of the arc. And I can move that anywhere, right? Just rounding issues here, but it still holds up. I can change my point of tangency like that. And now when this is a diameter, right, we know they're perpendicular. So See, that's 90 degrees, and of course that's 180. So that's our first theorem. All right, let's go back to my iPad and let's write that down. All right, so what are we going to be writing down for this theorem? The measure of an angle formed by a tangent and a chord intersecting at the point of tangency is equal to, all right, very good. It's equal to half the measure of the arc intercepted, right, formed or subtended, intercepted by that angle. And we did this in the calculator, which was not a proof, so now let's prove this. So let me draw a diagram first. I got a circle. I got a tangent line to the circle, which means it's going to intersect at one point, like so. And let's draw in a chord to this point of tangency, something like this. So let's call this chord A, and I'm going to call this tangent line BC. And I want to call the point of tangency, this point over here, T. So we're going to call the chord AT. All right, and this is going to be in circle O. All right, so there's the setup. We got a tangent line and a chord intersecting at the point of tangency, so that's going to be our given. So in this proof, what are we given? We're given circle O with tangent line BC, tangent at point T. And we're also given chord AT. All right. So based on what we saw in the calculator, what are we trying to prove in this diagram? Well, the theorem says that this angle here is going to be half the measure of that arc. So we're trying to prove that the measure of angle ATC is equal to half the measure of AT. All right, so there's our setup. How are we going to prove this? So I'm actually going to pause this recording. I'm going to write in all the steps and just talk through it. So let me pause. All right, guys, I'm back. So I wrote down all the steps of this proof. I didn't provide the reasons, all right, but I'll talk through them. There's 10 steps to this proof. I forgot step 0, which is to write out the givens. So make sure you have those. And yeah, so let's go do this. So step 1 or 2 is to construct the diameter TD. So I made this diameter right there. And I constructed diameter TD. And I also made chord AD. So I have this nice triangle now, ATD. All right. So if you want, you might want to just read through the steps and see if the proof makes sense on your own first. All right, I'll freeze it here so you guys can copy it down if you want as I talk through this. All right, but that was the first step. I constructed that diameter and that chord, right? And the reason, of course, is because between any 2 points, only one line segment can be constructed. All right, so step 2 is angle DAB is a right angle. All right, that's the wrong angle. Let's just say DAT, sorry. So angle DAT is a right angle. Oh, why is that a right angle? Well, because isn't this a diameter, right? Which means this is 180 degrees, right? And if that's 180 degrees, this is an inscribed angle, which is going to be half the measure of 180, and so that's 90 degrees. All right, so step 3, angle 1 and angle 2 are complementary. So I made these guys angle 1 and 2. This here is angle 1. This here is angle 2, right? And the reason for that is in a right triangle, the two non-right angles are complementary, right? These add up to 90 degrees. All right, step 4, DT is perpendicular to BC. So DT, this guy is perpendicular to BC, right? And we know that from one of our theorems that a tangent is perpendicular to a radii or a diameter at its point of tangency. So those two guys are tangent, sorry, not tangent, those two guys are perpendicular, so that is a right angle. These are right angles. All right, step 5, that was step 5. Nope, that was not step 5. Step 5, angle DTC is a right angle, right? So that's going to be a right angle because perpendicular lines form right angles. Step 6, angles 2 and 3 are complementary. So which angle do you think I mean angle 3? Well, that's going to be this angle, ATC, right? Angle ATC is going to be angle 3. So angle 2 and 3 are complementary because they form a right angle. And here's the good one. Measure of angle 1 is equal to the measure of angle 3. So why would angle 1 be equal to the measure of angle 3 here? Well, this is a good reason. I haven't used this in a while. But aren't they complements to the same angle, right? Angle 1 and 2 are complementary. Angle 2 and 3 are complementary. Therefore, 1 must equal 3. Complements to the same angle are congruent, or we can say they're equal in measure for this case, right? So isn't angle 1 here an inscribed angle? So therefore, it's going to be equal half the measure of the intercepted arc, right? That's the reason for step 8. And then step 9, well, we just said this angle, angle 3, was equal to the measure of angle 1. So doing a substitution, we can now say that the measure of angle 3 is equal to half the measure of this intercepted arc, right? And measure of angle 3, that was angle ATC, and that was what we were trying to prove. So we have shown that given a tangent line and a chord drawn to this tangent at its point of tangency, that this angle is going to be half the measure of the intercepted arc, right? Just like an inscribed angle. So there we go. So let's use this theorem to answer a couple pretty simple questions. If the measure of arc AT is 90 degrees, find the measure of angle ATC. So if the measure of arc AT, all right, here's AT. If this here were 90 degrees, find the measure of angle ATC. So if that were 90 degrees, this would be half of 90. This would be 45 degrees. Right, and couldn't I also ask you to find this angle? Right, so we can do this a whole bunch of ways now. Well, we know they're supplementary, so that has to be 135 degrees. That's one way. But couldn't we also use the theorem going the other way? If measure of arc AT is 90 degrees, isn't the major arc AT, or arc ADT, well, 360 degrees in a circle, so that's going to be 270 degrees. And looking at this angle here, ATB, well, that's also an angle formed by a tangent, right? And it's chord, so it's going to be half its intercepted angle. So this huge angle here is going to be half of 270, which is, again, is 135. So the more we know, the more ways we have to do these problems. So yeah, you can do it a whole bunch of ways. if I ask you to find those angles instead. Letter B, if the measure of angle ATD is 40 degrees, find the measure of major arc AT. So I'm actually going to erase a whole bunch of this because it's getting kind of messy. I think I'll leave that. All right, so ATD is 40 degrees, ATD. So that was measure of angle 2, right? That's 40 degrees. We're looking for the measure of major arc AT. So we're looking for the measure of this arc, AT here. All right, so if we know that's 40 degrees, well, we know that is 80 degrees, right? Because that is an inscribed angle. What else? Well, if that's 40 degrees, we also know that sum of angles in a triangle is 180. So that's 90 plus 40. This here will be 50 degrees, which means this arc here, because it's also formed by this inscribed angle, right? It's going to be 100 degrees. And I guess that's kind of obvious because, well, dt is a diameter. So, of course, that's going to be 180 degrees. So that was a silly question. But that means this piece here, dt, that's also 180 degrees. And so we have 80 plus 180. That's going to be the measure of major arc AT, which is 260 degrees. Right? And then I could have then asked you to find the measure of angle ATB here, right? And that would be 130 degrees. And that would use our theorem that, again, that's half of the measure of the intercepted arc. So there we go. And let's take a look at our second lab. All right, this time I gave you directions. So go ahead, try this on your calculator, see what you can set up, and see if you can notice any relationships. All right, let me switch to there. Go ahead and pause the video and try it. But here we go. All right, so here is my diagram for the second lab. So I made a circle. I constructed two chords intersecting within the circle, and there's the point of intersection, which I marked. Measure one of the four angles formed by the two intersecting chords. So here's the angle I measured, and also measure its vertical angle. I didn't do that because obviously they're going to be the same, right? This will also be 52.7 degrees here. And the last step says measure the sum of the two intercepted arcs formed by the angles in the previous step. So here is one of the angles from the previous step, right? Here's the arc. Here is the vertical angle. Here is the arc that it intercepts. So I want to measure the sum of these two arcs here. And so let's see what happens. So again, I have an extra point in here because I drew in the arcs. So again, that's 4, and then circle arc. Make sure you draw both arcs before you can measure the arcs. And I'm going to measure the circumference first. That's going to be 35.4, right? And then I'm going to measure this small piece, hit tab. That is 5.98. And I'm going to measure this small piece over here. That's 4.39. All right, so to get those arcs, the measure of those arcs in degrees, I have it set up down here. I'm going to do these two calculations. Here's the circumference again. So menu, actions, and calculate. All right, so for A, let's make that 5.98. For B, that will be 35.4. And so this guy here is 60.7 degrees. All right, menu, actions. I didn't need to do this again, but calculate. All right, C over D. I could have made a C over B. It's the same D, right? It's the same circumference. But for this calculation, that will be my numerator. This will be my denominator. And this arc here measures 44.6 degrees. So measure the sum of the two intercepted arcs. So one more calculation. I'm going to add those two arcs together. So I'm going to make it x and y. I don't know why they're capital. I think my caps lock is on, but it doesn't matter. So menu, actions, calculate this plus this. And that's 105 degrees. All right. So do we notice anything between this 105 degrees and that guy? Well, there's some rounding issues right now, but hopefully, oh, let's take a look. There's a relationship between 121 and 60.5. Is there a relationship between 93 and 186? So hopefully we're seeing, this is equal to, this angle is equal to half the measure of the sum of these two intercepted arcs, right? 186 divided by 2 is 93. So let me actually include that in my calculation. Let me make this x plus y divided by 2. And, now we can see they are exactly the same, 65.8, 65.8, right? And of course, this would have worked for these two angles up top. If you measure one of these angles, right, then you measure this arc on top, this arc on bottom, and you're going to see the same relationship, which is pretty cool, right? And of course, I can adjust this however I want. Oh, now I gotta move that in there, right? And it still holds up. So that is our second theorem for today. Let me switch back to my iPad. Give me 1 second. All right, go ahead and fill in that theorem, see how you can word that. All right, there we go. So the measure of an angle formed by two chords intersecting within a circle is equal to half the sum of the arcs intersected by that angle and its vertical angle. All right, so let's prove this theorem. This theorem is actually a lot easier to prove than the last one, so I will do the steps with you. And let's do a diagram. So here is our circle. Let's draw in two chords. Let me call this chord AB. And let me draw another chord. There we go. Let's call this guy CD. And let's have them intersect at point E. And as always, I'm going to call this circle O. So in circle O, we got two chords intersecting at E. And we're trying to prove the measure of one of these angles here. For example, like AEC, that's going to be half the sum of the measure of arc AC plus the measure of arc DB. Right? Divided by 2 is going to give us the measure of that angle. So there's my setup. There's my given. So given circle O with chords AB and CD intersecting at E. We're going to prove that the measure of angle, so I'm going to call this angle AEC. Let's prove the measure of angle AEC is equal to half the measure of these two arcs. So half the measure of arc DB plus measure of arc AC. So BD plus AC. All right, so I should also do the same for the other vertical angle. Let's also prove that the measure of this angle is also, of course, equal to the same thing. So the measure of angle DEB, let's also show that is equal to half the measure of the sum of the intercepted arcs. All right. Like I was saying before, right? Again, we can also show it true for these two angles, but I think that's enough just doing this. Redo. There we go. All right. So for this proof, what am I going to draw in? Well, I'm going to draw BC. That's going to be step 1. Right? And once you draw that in, I think you can try the proof. That's just the hard step to see. But if I draw in BC, well, what have I done? Haven't I formed an inscribed angle, right, to arc AC here? So, and also formed an inscribed angle, right, DCB to arc DB. So let's label these two angles. That, come on, get real close here. No, one more try, sorry. Oh my goodness. Just want to delete that. Okay. That was a waste of time. I'm sorry. I'm going to call these angles 1 and 2. Pick a different color. 1 and 2. So can I say that the measure of angle 1 is half the measure of arc AC, and the measure of angle 2 is half the measure of arc DB equals half the measure of arc AC, and measure of angle 2 equals half, I don't know why our parentheses are weird like that, I don't have any parentheses, half the measure of arc BD. Right, and we know that is because an inscribed angle is equal to half the measure of its intercepted arc. That was a theorem we proved earlier on. Right, so same reason for both of those. Step 3, here's where it gets interesting. What is the measure of angle AEC equal to? Well, isn't that going to be equal to the measure of angle 1 plus the measure of angle 2? Right, because this is an external angle, right? And the external angle in a triangle is equal to the sum of the two remote interior angles, or non-adjacent interior angles. And I can use the same reasoning for this angle. The measure of angle DEB is also going to equal to the measure of angle 1 plus the measure of angle 2 for the same reason. So the measure of angle AEC is equal to the measure of angle 1 plus the measure of angle 2. And for the same reason, the measure of angle, what's the other angle? DEB is also equal to the measure of angle 1 plus the measure of angle 2. You can also just say they're vertical angles, so they're also equal. Lots of ways to do this. But lastly, well, can't we do a substitution now? Here's the measure of angle 1. It's half of the measure of arc AC. Measure of angle 2 is half the measure of arc DD. Let's do a substitution, and we are going to be done with our proof. Because step 4, once I do that substitution, the measure of angle AEC, it's going to be half the measure of arc AC plus half the measure of arc BD. And that's the same statement as that if you distribute. So if you want to say factor out the half or something like that, go ahead. But I don't think that's necessary. I'm just going to do that. And step 5, same thing for this once you do a substitution. And so we have done this proof. So when you got two chords intersecting in a circle, these angles here are going to be equal to half the sum of the two intercepted arcs, right? And if you want to do a full proof, we could have proven it for the other two vertical angles, could have proven it for this angle and this angle, right? If you want to do that proof, right, we can just draw this segment or that segment, and you can take it from there. It's going to be the same exact steps. All right. So to finish this up, let's practice with this new theorem here. Find the measure of angle 1 in the diagram below. So 2 chords. This angle, therefore, is half of 55 plus 65. All right. Why don't you guys try these on your own? Just check. Hopefully, you're just checking now. So the measure of angle 1 is going to equal 55 plus 65 divided by 2. And what is that on top? 110 plus 10. 120 over 2 is 60 degrees. All right, so this is 60 degrees, which means this is also 60 degrees, which means that is 120, and that is 120. So we need that for the second part, which is a little more interesting. Find the measure of angle, it's not angle, find the measure of arc AB if the ratio of measure arc AB to arc CD is 3:5. So if the ratio is 3:5, well, whatever this arc is, this will be 5/3 bigger. So that was a bad explanation. Whatever this arc is, we can call that 3x, and we can call this 5x, right? Because when I set up that ratio, 3x over 5x, right, that's equal to 3/5. So when we get a ratio question, right, that's how we've been setting these up. So what does 3x plus 5x have to equal? What do the sum of these two arcs have to equal? Well, we already know these two arcs equal 120 in total. So can't we say that the measure of arc AB plus the measure of arc CD, that has to equal, well, if these are 120, right, this is the entire circle, 360 minus 120 is 240 degrees. So the measure of these two arcs here has to be 240, right? Or if you want, you can just add up the entire thing. You can go all the way around the circle. You can say measure of arc AB plus measure of arc AD plus that arc, right? That's 360 degrees, and you'll get back to here, however you do it, right? Well, AB, we said, was 3x plus 5x equals 240. So 8x equals 240, and x is 30 degrees. So if x is 30 degrees, the measure of arc AB is going to be 3 times 30. That's going to be 90 degrees, which would make this DC 150 degrees. 90 and 150, and that is, of course, going to be a 3:5 ratio because 90 over 150 is 3/5, right? Because 3x over 5x was 3:5. So that's how you do those ratio problems. And if you want to check, 90 plus 150 is 240, right? And half of 240 is 120. So the theorem still holds for that. And that's how you can answer that one. All right, let's take a look at this one to the right. Find the value of x. So we're given the angle formed by the two chords. So we know this 55 degrees, that's going to equal half the sum of these two guys. And you guys know what half the sum is? That is just the average. So you can also think of this as the average of the two intercepted angles. So we can also say 89 plus x over 2, right? That's the average. So 110 equals 89 plus x when you cross multiply. What's 110 minus 89? I think that's 21 equals x. So x is 21 degrees. All right, that's going to be it. We're going to have a short homework on these two theorems due on Friday, yes, and along with another homework tomorrow with a lesson tomorrow as well due Friday. All right, so I'll get the tests back to you guys soon. And yeah, see you guys later. Stay safe and take care.